Hey guys, my friends, welcome back to the shop. For this video episode, I get a lot of emails from people asking me, how did you do that? How do you get extreme precision? How do you stop chatter? And so on. So I thought I would just answer the most frequent questions that I get in a video. So, for what it's worth, maybe somebody will learn something, maybe not. These are just a few of the little kind of tricks, I guess I'd call them, that I do in the shop. So, I hope you enjoy and see you next time. Okay, as far as these little good guys are concerned, a lot of people don't know what the two side grooves are for, why they're there. Yeah, this is for checking a tool. If you're grinding, a threading tool, this you can be used too. But if you go to a trade school, they make you do what I'm going to show you. What's this for? Put it up against your chuck, your square. Now you can make sure that your threading tool is straight. If the bigger one, this is my bigger one. This one's capable of doing 18 TPI. But if you have a bigger tool like that, then yeah, you're going to use you can use the small side or you can use the bigger side to make sure your tool is straight. Bring it over, bring it out a little bit. So there, put it right on there. Oh, I should have been higher. But that's what that's for. And again, if you go to a trade school or something like that, they make you do this before you thread. Yep, okay, camera zoomed in, looks pretty good. Everybody talks about hot bluing, and it's always curious, why do you call it bluing when it comes out black? But I like the blue, the really nice blue. Here's a picture of it, because it's really hard for the camera to pick up the color. So I'll show you how I do it, just a regular torch, nothing big deal. But okay, turn it on. Hopefully I don't melt my microphone wire or the camera. Come on, there. Low heat. I don't want a big flame. A little bit more than that for this part because it's pretty big. You just start going over it, getting it hotter and hotter. But the key is you gotta stop and let the heat even out between the part. So I'm stopping for a minute. You're looking for when it starts to turn brown. When you see brown, you are ever so close to the blue. And I'll heat the middle up a little bit more, but usually it's the ends that are cooler. Whoop-oo. No, that's not. Alright, let it even out. All of a sudden you'll see brown show up and back off immediately. And let it even out. So, getting there, I know it. It seems like this left side here, this side, wants to turn brown, but I'm going to back off for a minute. I've got to be really close to going brown now. Alright. Kind of evenly do it, I guess. It's hard to judge what to do. Man, that's got to be really close to going right now. Still don't see brown yet. Oh, I gotta clean my torch up. I see red in it. It should be all just a blue flame. So there's contamination on there. Come on, you gotta be going soon. Don't see it yet. Jeez. Alright. Because if you hurry it up, all of a sudden you ruin it. It turns black or it goes beyond the blue color. Almost, huh? Gee. Probably need more light than this. Soon, please. Still nothing. Alright, turn the flame up a little bit more. Wish I could find this hot brick, something bigger. I think I got it off of Amazon, but I can't find it now. There, brown. Just see brown starting in the middle. See it? And it's evenly spreading. Teeny bit more heat on the ends. There, the whole part is starting to turn brown, more. Because the next step is going to be blue. It's actually, there it went, blue. Now I got to see where I need just a tad more heat. Blue's going fast. This end. See how little bit of heat I have to apply? There it goes. That's it. One spot here. There, went blue. Torch is off. Now I just let it sit and cool off. The mistake I made is don't blow on it to try to cool it off, because it'll roll off and light your bench on fire. It's changing, it's oxidizing right now with the air, and I see a beautiful blue. When it cools down completely, I'll take it over and I'll just put oil on it to seal it. I don't think that seals it, but it makes it look really nice. I don't know, I hope the camera can see this blue. Let me try turning a light on up here. There. That will not rust, ever. I did one steel part years and years ago, 5-6 years, been in a drawer, didn't put oil on it, and it's still the same as the day that I blued it. It just does not rust. So to me, this is what you call bluing, not blackening. So just wanted to share that little trick. I just wanted to throw this out there for fun. A long time ago, when I first started my channel, there was a trade school instructor that caught onto my channel, was leaving comments, emailing me advice, teaching me some stuff. And he had the books that he had that were his personal books, the instructor manual and the school manual, trade school manual that he used to teach from. He took the time to write notes in it and mailed it to me. So I had this practical machinist book and the instructor manual. But going through the manual, they had this wrench in there, and they showed, you know, the correct way to use it. You pull it this way, you do not do this. But in any case, I started thinking about it, and I've always called it a crescent wrench because my dad called it a crescent wrench. And I started thinking, why does everybody call it a crescent wrench? This is not a crescent wrench. In the book, it's called an adjustable wrench. This is a crescent wrench because it says Crescent on it, and it's made by Crescent. So I started thinking, everybody I know, I got dirt on it, everybody I know calls that or this a crescent wrench. Is it? I did do some research. I forgot the dates when Crescent first patented it and came out with it, but it was invented by, I think, a Swiss guy over in Europe, and it came to the United States at some point in time. But I'm just curious, how many people out there also call this a crescent wrench? I've never heard of anybody calling it an adjustable wrench. So yeah, I've always had these used tools and stuff, so I finally said forget that, and I bought the entire set of crescent wrenches. So now I have a crescent wrench, or wrenches. I can officially call them that. I don't have to call them a crescent tooloy or something steel. Oh, they even have an arrow on here to show that you are supposed to tighten this way, and I guess you loosen this way too. But yeah, that practical machinist book explained everything you need to know about a crescent wrench, or to call it correctly, an adjustable wrench. And I hope the microphone picks this up. Bring the camera up a little bit. Just an ordinary vise, but this is a little trick that I learned from my dad, and I have used it for years and years to check things. I see a lot of people using files and all kinds of things to check the hardness of different things that they tempered or whatnot. This is the trick right here. This is obviously high-speed steel drill. Listen to the pitch as to how hard it is. This is a lot thicker, 1/2 inch. Pitch does not change. Doesn't matter what the diameter is. This is a Harbor Freight punch set. Pretty soft compared to the drill bits. This is Dee's punch that he made and he hardened. Pretty darn hard. This is the Harbor Freight set that I've been bluing. I showed the blue procedure. Doing that and letting it cool down should have softened it. Pretty high pitch, still hard. You can hear the difference here. Yeah, it's softer compared to the drill bits. That's real low. This isn't hard at all. So yeah, looks like I pounded it and it is just flattened out here on the tip, whatever I was doing. So I just wanted to share that. That's a little trick. If you want to see if your hardening procedure worked, just tap it on something hard and solid. Okay, not sure too many people know about this. I was watching a video here a couple of weeks ago on a simple method for blackening steel. Now that I showed my bluing technique, but the guy did a bunch of different chemicals, salt, vinegar, this, that, but at the end, to actually turn the stuff black, he boiled it in dihydrogen monoxide. Okay. dihydrogen monoxide. So of course I went on Google trying to figure out, can I make this stuff? Can I buy this stuff? Turns out it's very dangerous. It's responsible for suffocation, transmitting E. coli, a whole bunch of things here. And there's even a website, advisories and alerts concerning this stuff. So I thought, wow, okay. But in any case, it said it's colorless, odorless, tasteless, this, that. A whole bunch of websites talking about this stuff, and he boiled the part in it, and yeah, it turned black. So, to let you guys know what dihydrogen monoxide is, it's the chemical name for drinking water. It's water, that's it. And it's a big ruse, whatever, however you say it, going on about the stuff. Yes, you can suffocate if you're in it. It will transmit E. coli and so on. So I just wanted to share that because I thought it was really funny when I discovered it. And why this guy decided to use the chemical name for drinking water, I have no idea. Alright, I just want to talk about chucks for a minute. Let me raise that. Yeah, that was probably good. Alright. So I think everybody knows I own a mini mill, small, and a mini lathe. So when I started years and years ago, I had no idea why they would send it with a massive chuck like this. But again, I didn't know, so end mills fit in it, use it, and drilling, so crazy. But in any case, back then I didn't have the second gear rack doubling my height, and I didn't have the lathe bed extension taking it way out. A lot more room now between the chuck and the tailstock. It was also when I didn't have the extended bed because I put the bigger chuck on it, which took it out further, so now I really didn't have much room. So I had to pay very close attention to the size of drill chuck that I put in the lathe or the mill. This was the first chuck that I had bought, because finding a small chuck that fits the machine is easier said than done. But what I want to get at here is, note on this type of chuck, there's nothing keeping the teeth, jaws, from going to the side when you spin it. Well, actually this one, this was just pushing on it. But nothing keeps them straight. So they can go at an angle and stuff. So what happens is when you put something in the chuck and you tighten it down, the jaws are kind of at an angle and you wind up with run out at the tip of your drill bit, your reamer, whatever. So the trick was, what I discovered is after you capture it, go back and forth like this a little bit, a few times. It settles the jaws down. They're now straight, so all the peaks to each jaw is straight, and you'll see that the run out disappears. The wobble isn't there anymore. So that was the first one. Then shopping around on eBay, I like, now why am I drawing a blank? Jacob's chucks, they're nice. This guy, you can see, has a little pocket for each jaw, trying to keep them straight as you tighten this thing down. But I discovered even with this chuck, same kind of problem. I'll put something in it, open it up. I'll put something in it, tighten it down like that. I'll look at it when I turn the mill on and I'll see run out. So I'll do this a few times and suddenly the run out is gone. So that's just kind of a little thing that I just discovered and came up with to get nicer holes, keep things from walking around while I'm starting to drill. After that, I said I'm tired of the key. I want a keyless chuck. I want it precision. If you look at this guy, this was like $300 to $350, outrageous. Later I discovered this one for $100. But if you'll see, there's a blade in between each jaw to keep them straight. So these are the only ones that I can just clamp down and that's it. I don't have to do my forward backward trick or anything. So I like this guy. I kind of very rarely use it after finding this guy. But if you look at this guy, this actually has like a jaw in between each jaw to keep it straight. And this one actually goes down to 0. So this is the one that I used when I was making those MIG tips, and I was trying to drill it out to 30 thou with a 30 thou drill bit. But yeah, if anything, when you have that small a drill bit, if you're off at all, that bit will snap so fast. The other thing that's hard too is finding an arbor that, like for this one, fits the tailstock, MT2 I think it is, and also fits this. Some of them are JT press fits, some of them are screw on. This guy I think was a screw on, yeah. So for what it's worth, this is an EL 0 to 1/4 3/8 24 thread down here. So I did manage to find an arbor for it, and all of them of course are way too long. They got that tang on the end. So I use the angle grinder, cut it off, throw it in the D-bit grinder, and clean up the end of it so it looks like it came from the factory. Same way when it comes with reamers. They're like way too long. I still cannot hold that. So all of them, I've taken the angle grinder, cut them off, go clean them up on the D-bit, chamfer the edges, rotate it, and now rather than this huge box that they came in, they're now in a regular jobber length drill index. So that's just kind of one of the little secrets. Same way with the Jacobs. I do have the bigger ones. I go on eBay, and some of them you can find new old stock where it's in the box, never been used for 50 years. So yeah, the grease is all set up. You can't rotate it. So I'll take them to the arbor and I'll break them down, completely rebuild them, put them back together. Some of them were used, so I could find new old stock jaws, replace the jaws. So everything I have is absolutely cherry. It won't go in the drawer unless it's been completely rebuilt and I know it's like perfect. So just wanted to share that little bit. Researching tools. Which way do I have to go? That way. Okay. I did a video on researching tools a long time ago, probably 8 years or something like that. But when my dad passed away, I inherited a lot of tools. And I know these were from back in 1940 or ish, somewhere in there. Now, look at this thing. I have used the heck out of this. I've beat up broken rocks with this thing, all kinds of stuff. And it hasn't come loose. The handle's perfect. Yeah, the paint's coming off of it. But in any case, researching them though, this is made by Plum. And it was a big discovery on Plum. The original company was called Plum, making a bunch of different tools at that time. There was another company that came out that spelled Plum differently. And there was a big, long patent infringement or whatever lawsuit that went on for years. And I do have hammers from the other company. So that was, one I'm looking at on the wall right now is from Fremont. That's another one to research. But it's really interesting finding out all the manufacturers, the companies, their history, what they made, and so on. Another one was this wrench. When my dad passed away, this wrench was on his workbench, and I'm thinking, why does he have this out? I mean, you can tell it's old. It is forged. It wasn't machined or anything. I think the jaws were hand ground on a grinding wheel, but whatever. But researching it, I found this wrench and a number of other ones, pictures exactly like it. None of them had a manufacturer name on it. Turns out, my dad was Air Force, World War II, repairing airplanes. This was the tool that he used in the Air Force to work on the engines. And it just happens to fit the nut on a radial arm and a table saw. That's why he had it out. But again, and then later on finding out who started manufacturing these wrenches for the Air Force and commercial places. So, you really want to cherish some of this stuff. Looks like it's starting to rust a little bit. I've had this in my dad's old toolbox forever just to protect it, I guess, or whatever. But what I'd say, I encourage people to look up anything that you have, old tools. I will only go for old tools. That's why I love swap meets, estate sales and stuff. If they've got an old tool, man, I'm buying it, because they just last forever. The newer stuff, US, China, doesn't matter. I don't know, just not the same quality. All right, here's another little kind of secret or caveat, whatever you want to call it, that I've discovered. Let's say you're trying to make a part within a thou or less. You're looking for precision. So you got your part in the vise. This also applies to the lathe. But you're in your final cuts. You only have a few thou more to go. So you're going to be just climb milling because you want a nice finish on the part. So you measured your part and you have 5 thou to go. So you dial in 5 thou and you come across with your cutter climb milling, and then you measure it and it didn't take 5 thou. You got 2 thou to go, but you don't think about it. But why did it only cut 3 thou off? Because the force trying to cut is pushing the end mill away. It can't cut that deep. Kind of exaggerating with 5 mil, you can say 10 or 50 or whatever. But the point is the machine flexes, so it's pushing the x-axis that way, it's pushing the y-axis that way, away from the cutter, and it's tilting the column on the mill. So now you got 2 thousandths to go. It didn't take a 5. So you dial in 2, and then you come across again, and all of a sudden the cutter now, the force is a lot less. It's not pushing the end mill away as much. So it's cutting in 3 thou because it's starting to cut now part of the material that was left from the 5 thou cut. So now you measure it, it took 3 off, so now you blew it because you're off by a thou, you're too small. So that's kind of the point, the forces are pretty high and it starts pushing everything away from the end mill. How do I solve that? When I did that 5 thou cut, I'll just keep going back and forth until it stops cutting. Then I can measure it and go, yeah, it finally did take the 5 thou, so I only have my 1 thou left to go. Now I can climb mill, face it off with that 1 thou final cut, and I'm at dimension. This, like I said, also applies to the lathe, because the compound, everything moves, tweaks, bends, twists. So I'll do the exact same thing on the lathe. I'll just keep going back and forth with the cutter until it stops cutting the part. Then I'll check the diameter and do my final cut. So that's just one little caveat or whatever that I kind of discovered. So this is how I'm able to get things down to 1/10 of a thou. All right, one last little tip or secret, caveat, whatever. Chatter. And I did see a YouTube video explaining it, and it made complete sense. Now this only applies to when you're doing this kind of cutting. Doesn't matter whether it's climb or conventional milling. What's happening is, like I said, the mill flexes. Everything's moving. If you're using a cutter like this, it's got a very steep helix to it. So if you look at it as it spins, at one point in time, one of the cutting edges, the flute, is touching the part, but as it spins, there becomes a dead band where nothing is touching the part. As a result, the flex disappears, the end mill goes closer to the part, the surface that you're cutting. Then when it comes around again, all of a sudden another cutting edge hits it, and it pushes the end mill away. So what's happening is the end mill is now bouncing back and forth on the surface, causing that high frequency chatter sound. How do you get rid of it? Well, next, this is another one. This is a one I got from Traverse Tool. It's designed specifically for aluminum, and it's got a ridiculously steep helix to it because it wants to clear the chips as fast as it can. If you don't clear the chips on aluminum, this is specifically for aluminum, if you don't clear them, they start gumming up the cutting edges. Aluminum's a gummy stuff, even if you use cutting fluid. So this guy creates a tremendous amount of chatter. So I don't use this for doing this kind of a finish. I'll do the top only cutting edge. So again, how do you get rid of it? You use an end mill that's got not as steep of a helix. So on this one, as it spins, this cutting edge is touching, then this cutting edge is touching, and then this one. So there is no dead spot on this. So the point is, you have to look at your end mills and realize what you can do, what function you can do or cut, and what you cannot do with that particular end mill. So that's just something, once I tuned into that, I don't get chatter anymore. I get nice finishes when I'm doing this type of a finish because I use something with a low helix. I actually have one, I can't find it, which is almost horizontal. So that's the best one that I use for this type of finish.